Welcome, my name is Vince, and today I want to talk a little bit about Coax. Have you ever asked yourself the question, what is my Coax doing? I can understand that. I like to know how things work too, so today I'm going to go over how your Coax works. Let's hop over to the computer. Okay, so let's say you look at your Coax from the end, and you will have your center conductor, which will be copper. Then you'll have your copper braid, and around that you will have your black rubber insulation. Now I know I wouldn't win any prizes in art, but I am drawing with my mouse, so please excuse my artwork. Pretend this is round. Okay, so just a quick recap. We have the center conductor, which is copper. Then we have our dielectric here, which is either foam or air. And then this here will be your braid, your copper braid around the outside. And then this outer layer will be your coating or your insulation. And what you're going to have is, you're going to have a current right here coming up here to your antenna. So let's make that a positive. Then out here, right on the outside of this shield, you'll have the current going back to your transmitter, which would be, let's say it's a negative current. It's actually flowing back towards the transceiver, so I'm just using this as an example. Now we're dealing with coax. It's different from ladder line, but you also have a few things going on. What you will have is, you will have an electric field in here, and it will be running in this area, and you will have voltage, but you will have a voltage difference from the center here out to here. So since this is energy, now in here you will also have a magnetic field, which will be flowing around the center conductor, and it'll be going in a direction. Also on this outer conductor, you will have a magnetic field that will be flowing in the opposite direction. Now the difference with this magnetic field between ladder line and coax is that this center magnetic field cannot escape outside of this shield. I guess you could say this shield is actually a Faraday cage around this center conductor, keeping that magnetic field in, but I'm just using that as an example. Now what will happen is, with this magnetic field going this way, and it's going all the way out to this conductor on the inside, and then you got this magnetic field right on the outside. What it does is, right on the outside of this, you also have it flowing around this way, like this. And what they will do is, these two will cancel themselves out. Technically not have any magnetic field. You'll be hard pressed to find one. So this is why you can lay coax up against your tower, or up against a metal pipe, or up against a rain gutter, and the objects don't affect it, because of this cancellation effect right here. Now another advantage with coax is it's also 50 ohms. Okay, now there is one area with coax that's different from ladder line, and that's where you can actually have an issue with it. And what we're going to talk about is this area right in here. So I'm going to blow it up. What you're going to have is, you're going to have one line, which would be the inside here, which would be your copper shield. And then you'll have the outer line here, which will be your rubber jacket or casing. And what's going to happen is, that current is going to ride right here, and then out here you're not going to have much at all, almost zero. And that's how you want it to be. Now if this changes and you start to get some current out here, what's going to happen is, your coax is going to start radiating, and it's going to become part of your antenna. And of course that'll mess up SWR and performance. Now, one way this would happen is when people use it to feed a dipole. So let's say we have our dipole, our terminal, and our dipole. And what we're going to have is our coax coming up, and we're going to have our center conductor, and then we'll have our foam dielectric. On the outside of that will be the shield, or the bare copper bond, and then you'll have your rubber casing. So the way this would get connected is this would go to here, and then coming off of your rubber casing would come up here to this one, and now that feeds both sides of your dipole. Now this looks good, and if it's a good match, it means all your power will be going out to the antenna. But the thing is, you're going to have a big magnetic field here in the center. Then out on the ends, you're going to have your electric field. So what's going to happen is when you start to transmit and your antenna starts to radiate, you have your magnetic waves coming out, and they'll be coming out underneath. They'll be coming this way, and they'll be going this way. And what's happening is, look where they're hitting right here on the coax. They're hitting that bare copper wire. And what this will cause is the current to come back down on the outside of this braid, on the outside of the coax, and that's what you would call common mode current. And that can cause you issues in your shack. The worst of these being could be like when you're transmitting and you're touching your receiver, you could feel tingling in your fingertips, or you could even get if you're using a lot of power, you could get a very light radiation burn. But even if you take and you ground this shield, it's still going to radiate, and it would still affect SWR and performance. Another thing you will have will be when this feed line actually starts to radiate, you'll be having them radiating outward in this direction and that direction and in all directions. And what it will do is it will actually be coming up and hitting this antenna and going into this antenna, and also affecting performance. Now the way to get around this is to use a Balun. And what the Balun does is it converts the balanced antenna to the unbalanced coax. It'll go right here in between the antenna and the coax. And what will happen is you will want the current on here to be the same as the current on here. So to achieve that, the Balun, what it is, it's actually two windings, one on each side, and then you'll have one center core, and then you'd have your outer shield, and of course on this foam part is where the copper braid would be. So what would happen is the center conductor would connect here, and this outer shield would connect here. But what it would be is there would be a Pl259 right here, and it would be screwing on to an SO239, and that prevents the problem we had with the antenna radiating across this copper shield and causing the common mode issue. Also, now these Baluns, you can either buy them or you can make them, and usually this part here will be in a waterproof box, and then down here would be where your coax would be. Now what the Balun does is it ensures currents on each wire will be the same by transforming them, and it can also block voltages. So let's say you had on this winding you had a 1.5 amp current, and on this one you had a 1 amp current. So what it does, it actually blocks this and makes it a 1 like this side. And it also blocks any current from coming back down this way that would end up going down your coax and making it radiate and become part of your antenna. Now another thing is, when you have an antenna that's both a transmit and receive antenna, and you get it all dialed in and you get it resonant and you get the ohms right where you want them. You have a thing called reciprocity, which means when your antenna transmits good, it will also receive good. And the Balun will also help to block this noise that's coming back down on your receive side. So it will also have another purpose of helping to keep your antenna on the quieter side, or at least not introducing any new noise into it. Okay, I hope you found this helpful. Please remember, a Balun doesn't hurt you. Some people say that the Balun robs a little power, but what you gain from having the Balun kind of overweighs a little bit. I mean, and it's minuscule, the amount of power you lose with the Balun. Please remember to like, subscribe, ding that bell, and a like's always appreciated. 73.